Let us look at the graph of the quadratic function below. So we want to find the function that represents this curve. And secondly, we want to determine the equation of axis of symmetry for this quadratic graph. So to respond to the first question, the function representing the curve. So as we can clearly see here that our curve is cutting on +2 on the x-axis, and it is also cutting on -1 on the x-axis. So let us get to the two values where this curve is cutting the x-axis. We are responding to the first question. We should find the function representing this curve. Okay. So step number 1, we see here that our quadratic curve is cutting on -1. That is the first value of our x-intercept. So we have x is equal to -1, the first value. Then the second value, this is cutting on x is equal to 2, like that. So x is equal to 2. So you can see why we are using x, because this curve is cutting on the x-axis. So this is the x value, 2. Then the other x value is -1 from the x-axis. So let's find the function. So what we do here is we cross over. This -1 should go on the other side. So we should have x like that. When it crosses the equal sign, it will be +1, like that. Once we do that, we enclose this in parentheses. Then on the other side, we have x is equal to 2. When this 2 crosses over, it will be x, the sign is going to change. So +2 crosses, it will be -2, like that. Okay. Now, we just have to apply the distributive law. So we get this x in the first parenthesis. I write it down here, x, like that. So this x. Then we get everything in here, that is x minus 2. So we have x minus 2, like that. Secondly, here we have +1. So we write +1, like that. Then again, we get the same pair, x minus 2, like that. Now we just have to simplify this. So we say x times x, we get x squared. Then x times -2, we get -2x. On the other side, we have +1 times x, we get +1x, or just simply +x. Then we have +1 times -2, we get -2, like that. Now, we identify the like terms in this function. So we have x squared, -2x plus x. This will give us -x minus 2, like that. So this is how far this thing can be simplified. So the final answer should therefore be f of x is equal to x squared minus x minus 2. So we have responded to question number 1. So the function which represents this curve should be f of x is equal to x squared minus x minus 2. But we have to look at the nature of the curve. So if you look at this curve here, it's upwards. It is giving a maximum value. When your curve is giving a maximum value like this, the value here in front, this x must have a negative. Okay, so our function must be multiplied throughout by a negative. So we say, therefore, the final expression should be negative multiplied by the whole function, since the function is giving us a maximum value. So we write negative times x, we have -x squared. Then negative times negative, we get +x. Then negative times negative, we get +2, like that. So this is the final answer. The function representing this curve should be f of x is equal to negative x squared plus x plus 2, like that. Then the second question says we should find the equation of axis of symmetry. So to find the equation of axis of symmetry, we have to look at where this curve forms the line of symmetry. So you can clearly see that the line of symmetry will be here, like that. So to find the equation of the axis of symmetry for a quadratic function, we just have to use this expression. We write x is equal to negative b over 2a. This is an expression which we use to find the equation of the axis of symmetry. We also use it to find the coordinates of the turning point, the x value of the coordinates of the turning point of the curve. So we write x is equal to, now from the expression we have over here, negative x squared plus x plus 2, we are supposed to find the coefficients. So remember, the number in front of this, the term with the square, is called the a. So the a, in this case, the number in front here is negative 1. Then we have the second number in front of this x to the power 1. There's a 1 here. So we say that's our b is equal to positive 1. So there's a 1 here. Lastly, we have this number, the constant. It's also known as the c. It is positive 2. So our a is the number in front of the square term, which is x squared. There's negative 1 in front. Then the b is the number which is in front of this x with a power 1. So b is equal to 1, the one in front, the positive 1. And c is the constant term, in this case positive 2. So for these coefficients that we have extracted from this function, we replace them in this expression and simplify. So we have x is equal to negative, we open parenthesis, what our b in this case is positive 1. So we replace 1 here like that over 2. Then our a is just simply negative 1. So down here we say negative 1. Then we have x is equal to negative times positive, we get negative. So we have negative 1 on top divided by 2 times negative 1, we get negative 2. We can simplify this further. So we write x is equal to negative divided by negative, we get a positive. So we have 1 over 2, like that. But this 1 over 2 can also be written as 0.5. So this is the equation of the axis of symmetry. X is equal to 0.5. So this is how we solve the quadratic. We find the function representing a curve of a quadratic function. Sometimes your quadratic function might face downwards like this, but passing through the same points like that. So if it is facing downwards, it will give you the minimum value. So when you have such a quadratic curve, you just have to get this one as your final answer, x squared minus x minus 2. But when you've seen that the quadratic curve is facing upwards like that, you have to continue from here. You introduce parentheses and multiply your function with a negative so that you should get the results of the maximum point.